Hello students, Mr. Bohoric here, and today I want to talk about cubes and cube roots. So you may have heard of cubing something before. Hopefully you've certainly heard of squaring something before. Well, when we square a number, we raise it to the second power. So that's like 4 squared. Notice it's being raised to the second power. And we say that's squaring something because, well, it basically will make a square with an area of 16 and the sides are 4 squared, hence the shape. Well, cubing something, it's very, very similar. It's not raising it to the second power, however, it's raising it to the third power. So let's say we have 4, but raised to the third power. And we call that 4 as being cubed. It's being cubed. And where in the world does that come from? Well, it comes from the shape itself. So if I have a cube where every single length, width, and height is 4, and hopefully I can draw this kind of well. I'm not exactly the best at drawing with this pen tablet thing. So 4, 4, and 4. Okay, that means that if we break this up in drawing the actual squares in there, I'm being very, very, very careful about this. You can see that we have 16 here on this front side of the cube, but we're measuring the number of cubes. This is very similar to volume. In fact, it's pretty much the same thing. So you can see, and this is really tough on the top. I made this too small. Ugh. I think I need to have another layer right there. There we go. Looks a little bit better, kind of, maybe not. It's good enough. Hopefully it illustrates the point. But you can see that what we have here is 4 on the side, 4 on the bottom here, and 4 right here. And this makes a total of 64 cubes, which coincidentally, if you did 4 times 4 times 4, 4 to the third power, it is in fact 64. So as you can see, the word cubed, it's just indicating that yes, you can make a cube, okay, from raising something to the third power. That's why we're allowed to say cubed. Okay? Same for squares. You can make a square by squaring something, raising it to the second power. All right, so just to practice a little bit, it's helpful to kind of get an idea of some of the basic cubes. So we'll start with, how about 2? And you go from there. So we want to know 2 to the third. So that's 2 times 2, a number times itself, times 2. So 2 times 2 is 4, and 4 times 2 is 8. So it's helpful to know the first couple of them, to kind of get an idea of like what the cubes root or the perfect cubes are. Let's go with 3 to the third. So we're doing 3 times 3, which is 9, and then times one more 3, which is 27. Very nice. And finally, let's go ahead and do 4. We already did it, but let's go ahead and just write it out. 4 to the third power is 4 times 4 times 4. That's 64. Okay, 4 times 4 is 16, times another 4 is 64. And just for the heck of it, why not? Let's do 5, because 5 is awesome. So 5 to the third, that's 5 times 5, which is 25, times one more 5 is 125. Sweet. Now, this is all nice and good, and we need to now talk about cube roots. So this is a little bit new concept, especially since this video is intended for pre-algebra. If we're raising a number to the third power, like let's say 5, we get 125. Well, what if I want to go in reverse? Well, this opens up another pair of inverse operations. I wouldn't want to square root it, but instead I want to find the cube root of it. It's written just like a square root sign, the radical here, except there's a 3 right there, indicating that I want the cube root. I want to know what times itself is 125. So I want to find the cube root of 125. And that is 5, because 5 times itself is 125. So we have to write that 3, indicating that we want the cube root. Okay, it's still the same terms though. This is still the radicand underneath here, so I should probably label that. This guy right here, that's the radicand. Always thought that was kind of a funny word. And the weird little check mark that is still the radical. Okay? It's just if we want to find the cube root, you write a little 3 right there. And it even actually extends further than that. If you say, I want to find the 4th root of a number, you could just write a 4 right there and find what times itself times itself times itself is the radicand. So let's practice with a few examples off to the side here. Okay, let's say I want to find the cube root of 64. Well, okay, you'll notice that in some of the examples we did over there, like this one, it's very helpful. Okay, I want to know what times itself is 64. Well, that would be 4. Okay, 4 times 4 times 4 is 64. Let's do another one. Let's say, let's do the cube root of 1. Deceptively simple. What times itself is 1? Well, 1. 1 times 1 times 1 is 1. And let's do a third one. Let's change it up a little bit. Let's do the cube root of negative 125. Now, with square roots, we cannot take the square root of a negative number. At least not in this class, we can't, okay, because it's imaginary. So, but we can do the cube root of a negative number. That's okay. In fact, this one, okay, you might already have gotten it. It's negative 5. Negative 5. Well, why is that? Well, because negative 5 times itself, so times another negative 5, times itself times another negative 5 is negative 125. Look at the negatives. A negative times a negative, that's a positive, times one more negative is negative 125. So this totally works. You can take the cube root of negative numbers. That's fine. Okay, square roots, you cannot. In fact, you'll learn later on that if you take the even root of a number, okay, that's negative, it's imaginary, and if you take the odd one, it's not. All right, so let's move on. Actually, you know what? I'll save this stuff with solving equations as radicals for the next video. So I'm Mr. Bajork, and that was cubes and cube roots.